Alright. Good evening everyone. Alright, so sorry we're starting late. Um had a bit of issues getting the notes on video record. Alright, so we start with motion quickly. We don't have time, it's not a new topic to us. So like I said yesterday in yesterday's class, as I'm looking at the topic, I'm also covering other areas revolving around that topic. So we know simply that motion simply means movement, all right, movement, mobility, the change of position of a body from one point to another point, as you can see on the screen. So we define motion as a change of position of an object with respect to time. You see the examples there. These are just preliminary introductions. We don't have more time to waste on this. All right, now motion is mainly described in the following terms. There are four quantities that describe motion. There are other quantities though, but these four lays the foundation for the description of motion. So we have distance. Distance, like we said, motion is the change of position of a body with respect to time. All right, now for a body to change from one position to another position, something must move the body. So that move is called force. All right, so force is any agent or anything that tends to change the position of a body from one point to another point. So one of the terms that define motion is force. Force is the mystery behind motion. Force is the reason behind motion. So the other terms, we have distance, displacement, speed, and time. All right, so distance is a scalar quantity. We all know what scalar quantity means. Quantities that have magnitude but no direction. Displacement is a vector quantity. Quantities that have magnitude, both magnitude and direction. All right, so example of scalar quantities, we have temperature. We have temperature in Kelvin. We have current in ampere. We have luminous intensity in candela. Then we have amount of a substance in mole. All right. We have time in seconds. These are examples of scalar quantities. The vector quantities, we have force, we have acceleration, force in Newton, acceleration meter per second square, pressure Newton per meter square. We have density and all that. So these are examples of vector quantity. Sorry, density is a scalar. Is a scalar quantity. A scalar quantity, not a vector quantity. Even though it can be expressed mathematically in a formula form, it is still a scalar quantity. So that's just the basics of motion. So what is speed? Speed is the rate of change of distance with time. And time is a measure of the duration of an event. The measure of the duration of an event. So these are the four basic preliminary quantities in which motion is described about. All right, so now like I said, distance is a scalar quantity, displacement is a vector quantity, but they are used interchangeably most times in physics. You can from the notes on the screen, we can see the we can see the explanation, the difference between them. We said, okay, and they are used to describe the change in position. All right, now if someone asks what is the distance between A and B, now we can't give a definite answer because the distance depends on the path taken. It may or may not be the same for all three paths as explained above. So this should give us some. The notes are very self-explanatory. It should give us a concrete idea of the difference between distance traveled and displacement. But the basic difference is that one is a scalar quantity, that's distance, which has magnitude but no direction. 4 kilometers, no direction, while displacement has both scalar and both magnitude and direction. And that's a vector quantity. Now, what are the types of motion we have quickly? What are the types of motion? All right, so we have we have linear motion. Some call it translational motion. Some call it rectilinear motion. It's the motion of a body um, along a straight path or in a straight line, having constant velocity or acceleration. The motion of a body, the motion of a car in the straight path. A boy walking on a straight road to school. That's a linear motion, rectilinear motion. All right. Then we have vibratory motion. Vibratory motion is sometimes interchanged with the word called oscillatory motion. Is a to and fro movement of a body, like the swinging of a pendulum ball. The to and fro movement of a body, that's vibratory motion or oscillatory motion. We have circular motion and rotational motion. Rotational motion is simply the movement of a body, is the circular motion or the circular movement of a body around its axis. Like, for example, the globe of the earth. That is a very classical example of rotational motion. And we see that the earth rotates. The earth rotates around about its axis. So that is a key example of rotational motion. Now, why circular motion is just the movement of a body along a circular path. Along a circular path. And there's a force that keeps the body moving around the circular path. That force is called centripetal force. Centripetal force is the force that keeps the body around a circular path. So basically, these are the four types of motion we have. So quickly, we're going to go into equations of motion and calculations involving equations of motions.